Alright, for section 3.5 in your college algebra book, this is going to be called complex zeros in the fundamental theorem of algebra. What it means by complex zeros is when you're going to find the zeros, this time you could potentially have imaginary solutions. So that's the kind of the key to it. As far as the fundamental theorem of algebra, that's just basically stating that you should have a plus or minus for your anytime you have a radical or anytime you have an imaginary. So anyway, here's the first example problem. Is they have something like this: x to the third minus 3x squared plus x minus 3. What they're going to ask you to do is they're going to ask you to find the zeros, and they're going to ask you to complete or find the complete factorization of it. So it's a couple different ways to attack it. For this particular section, what I'm going to do, or for this one, I'm going to factor it. Anytime you have four terms like this, I always try to group. So I'm going to group the first two with the last two. And in the first two, I take out what I can. So I can take out an x squared, leave me x minus 3. And in the back, I can't take out anything. Or if I do take out anything, it's a 1. Now when you factor by grouping, the thing that you want to see happen is you want to see that those two match, which they do. As long as they match, then I write it down once, because what I'm doing is I'm taking out this whole group, the x minus 3, out of both parts. And then in another set of parentheses, I'm going to write down what's left over. Well, if I take the x minus 3 out, I got x squared plus 1. Now, that's a complete factorization. Okay, because you cannot go any further with that. X squared plus 1 does not go any further. Okay, so as far as trying to factor that, it just doesn't go anything beyond that. Now, as far as finding the zeros go, what I would do is then set each group equal to 0 and solve for x. So if I add 3 over, I get x equals 3. And on this side, here's where the complex part comes in. If I subtract 1, I get x squared equals negative 1. And then when I square root, anytime you square root a negative, you should always get plus or minus, but it should be an I, because anytime you take out a negative out of that and the square root of 1 is 1, you always get an I. So for these, a lot of times you're going to have an I involved in your answer. So that's the first type where we're going to factor and then use that factoring to find the zeros. A second type is where we can't necessarily factor at all. X to the third minus 2x plus 4. Okay, where factoring doesn't necessarily work. And that says p of x. Sorry for that, I almost forgot to put that in there. But what we're going to do for this is we're going to do what we did in section 4, where we're going to use like Descartes' rule of signs. You're going to use all those different things in order to actually try to solve for x. So for this particular thing, if I were to list out all my possible rational zeros, I get plus or minus 1, plus or minus 2, plus or minus 4. Now, as far as trying which one, you can either use your calculator and see where it crosses. That might give you a little bit of a suggestion as far as where to start. Or if you simply just pick one. Now, I picked negative 2. And when I put that in there, I have to have a 1 there for the x to the third. I have to have 0 there for x squared, and then negative 2 for the x, and 4 for the constant. It's very important to make sure you put that 0 in there, otherwise you're going to be off. Now I'm going to synthetic divide it, and my hope is that I get 0 for the remainder. So if I multiply, insert it, add it, multiply it, insert it, add it, and I do get 0, and that's what I wanted. So this negative 2 up here is a 0. Now there's more than one 0. There should be up to 3 zeros for this one, because the highest exponent was a 3, but for this particular one, negative 2 was a 0. Now as far as what I have left, I have x squared minus 2x plus 2, and that's a quadratic, something we've been solving since chapter 1. When I have a quadratic, if I can't readily factor it, like if I notice that it doesn't factor right away, I always just use the quadratic formula, which again, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Or in this case, our b is negative 2. So I'm just inserting those numbers. Oops, I almost forgot the squared there. And then a is 1 and c is 2. Now it's very important that you actually get the formula written down right. One of the things I've noticed for students is that they constantly write the problem down wrong. As soon as you write the problem down wrong, you're shot. Okay, especially this squared right there is the big key, or getting the signs right for the back group is another one that it's a constant mistake that a lot of students make. But in the front we have two negatives would make that a positive 2, plus or minus. Negative 2 squared is 4, and then you have negative 4 times 1 times 2, which is negative 8, all over 2 times 1, which is 2. 4 minus 8 is a negative number. It's a negative 4. So like we said on the previous problem, when you have a negative underneath there, you take your I out, and when you actually take the square root of 4, you should get 2, but then don't forget the I should be there also. Now here's another big point that a lot of people screw up with, is that they divide these two first and then leave this till the end, and they don't ever divide it by 2. That's not the case. It should be where the 2 divides into each of them. If it doesn't, you can feel free to leave your answer that way, but for this one, they both divide by 2. So if I divide them both by 2, I get 1 plus or minus I, which is 2 answers. You have 1 plus I and you have 1 minus I, plus you have the negative 2, so that therefore giving me the final solution of 3 answers. Now as far as the complete factorization goes, x minus 2, or the negative 2 actually, when you rewrite it, would be x plus 2. And then the other one, if you re-multiply it back out, was this what you got before you used the quadratic formula. That's the complete factorization. Typically speaking, I like to try to find the zeros first and then do the factorization. I think it's just easier that way. But that's kind of one of those processes. Same thing goes for another type. Here, if I've got p of x equals 3x to the 5th plus 24x to the 3rd plus 48x. Now for this, I always revert back to factoring if I can. So for me, the first thing I look at is there anything I can take out? Well, I can all divide them by 3, and I can take an x out of all of them. When I do that, it gives me x to the 4th plus 8x squared plus 16. Now even though it's not a quadratic, it's what we consider a quadratic type, because we do have a 4 here as the highest exponent, and then half of that is 2. So that's a quadratic type. So when we look at that, we look at it as what times what gives me x to the 4th, which should be x squared and x squared. And what times what gives me 16, but adds up to be 8, would be plus 4 and plus 4. Now if you notice, it's the same group twice. So we can rewrite that as one group squared. So for that particular thing, that would be what they call a multiplicity of 2. Okay? So when you have the same group that shows up twice, we call it a multiplicity of 2. If it showed up 3 times, it would be a multiplicity of 3, and so on. Okay? Now as far as solving that goes, I would set each group equal to 0. So the 3x equals 0, divide by 3, x equals 0. Then I would go x squared plus 4 equals 0, x squared plus 4 equals 0. If I set them each equal, I'm going to get the same answer twice, but just to kind of show you that I do it the same way for both groups. And then from here, I square root both sides, and I get x equals plus or minus. Now I take an I out again, but then the square root of 4 is 2, so I get 2i. And I also get that over here. So that's where that multiplicity of 2 comes in, where a lot of times you could see this answer as 0, and then you would see 2i, and then they'll say multiplicity of 2, meaning it showed up twice, and then negative 2i, multiplicity of 2. So as far as the factoring goes, this is the factoring right up there. So we factored it, and then we also showed that we have the different types of multiplicities. So we're using kind of a combination of a couple different things that we've had in the past, plus just to make your problems look a little bit bigger. Then from here, they're going to give you some problems that is going to say, here's the answer. I want to know what the original equation looked like. So they're going to do something like this, where it's going to say, here's the zeros are -2 and 0, and it might say something like 2 has a multiplicity of 3, meaning that -2 really was there 1, 2, 3 times, and then we have 1, 0. So realistically, there's going to be 4 groups. Now what that means is that x would equal all those. So it equaled x. X equaled -2, x equaled -2, x equals 0. Then before it got to that stage, it would have been, if I move everything back over, it was x plus 2 equals 0, x plus 2 equals 0, x plus 2 equals 0, and x equals 0. I'm trying to get them into that before I set them each equal to 0, what they look like. Now before it hit that stage, they were all multiplied together. So I would have had x times x plus 2 times x plus 2 times x plus 2. Now, some people like to write it as x plus 2 to the 3rd power, but I found that most of my students, that they mess that up, because what they do is they just tell me it's x squared plus, or x cubed plus 8, and they just cube each part instead of actually writing out the 3 groups, or writing out the 3 different groups and then multiplying each one. Okay, because you're going to have to FOIL for this. They want you to find the initial equation. So for me, I start kind of in the back, and I'm just going to FOIL. And when I FOIL that, I get x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. And now I'm going to FOIL again, which is going to give me x to the 3rd plus 4x squared plus 4x plus 2x squared plus 8x plus 8. And then after combining like terms, I get x to the 3rd plus 6x squared plus 12x plus 8. And then I still have to multiply that by x to give me a final answer of p of x equals x to the 4th plus 6x to the 3rd plus 12x squared plus 8x. Now again, looking at the highest exponent, I have it as a 4. When it says -2 has a multiplicity of 3, that would mean 3 of those and 1 of those, 3 plus 1 should equal 4. So when they're telling you that, they're actually trying to get you to multiply everything back out and see what you come up with in the beginning. If it ever gives you an I in the problem, for instance, if they have something like this that has Q has a degree of 3 and zeros are 2 and I, you should have 3 groups, and right now it's only showing 2. It's only showing this one and this one, but realistically we also have a negative I there. Anytime it's got I, we should always have plus or minus. So to set this one up again, it's x equals 2, x equals I, x equals negative I, and then I bring everything back over so that it's equal to 0 again. So that's x minus 2 equals 0, x minus I equals 0, x plus I equals 0, and now I'm going to FOIL. And for when it comes to i's, I'm going to specifically multiply these two first, because the i's should end up canceling if I did it right. They are going to be complex conjugates of each other, meaning when you multiply them, they should go away. Or parts of them should go away, I should say. So when I FOIL that, I get x times x is x squared plus ix minus ix minus I squared. These two will cancel each other out. And I squared from previous sections is equal to -1. So x squared, that's a negative 1, which means that's plus 1. And now I FOIL it with my last one, and we get our final answer. So that's x to the third minus 2x plus, or 2x squared, sorry, plus 1x minus 2. And then it would equal, q of x, because we use q for this one. But anyway, if you look at section 3.5, they're going to ask you to factor it and find all the zeros for the first part, find the zeros, or find the polynomial with the specified stuff, or what, like this problem was here. So anyway, that's section 5.